This is the Quadratic In Form video solutions for the worksheets for your homework and equations that are reducible to quadratics. If you notice first off that our highest power here is a 4. Now that's not a quadratic. Quadratics have the highest power for x being 2. So as we discussed in class, in lecture, what you're going to do here is the following. You're going to let t be this middle term. In other words, t here is x squared. We're going to do a substitution of variables. So if this x squared is going to be represented by t, what happens is if I square both sides, like from the prior homework section, we get x to the 2 times 2, or really 2 squared equals x to the 4th. I can now replace this x to the 4th here with a t squared. So the reason we call this quadratic in form is because the first term now is t squared minus 13t plus 36 equals 0. This is now a quadratic equation, but in terms of the variable t, don't forget that t is going to be equal to x squared, and we're going to actually ultimately solve this equation for x, but first we have to solve it for t. This is quadratic in form now because you're dealing with a quadratic equation. Now, there's 2 ways to solve your quadratic. We can actually, well, there's more than 2, I think there's 3, but there's 2 ways that we've talked about in solving. One actually is from beginning algebra, which is really factoring and using the zero product rule, and that's my favorite thing to do. Or you can use the quadratic formula. So if you study the quadratic formula and did that homework, this would be a good time to use quadratic formula. Or you can factor. I'll factor. We need a product that's 36 and a sum that's negative 13. So that looks like it's a negative 9 and a negative 4. So now by the zero product rule, we get t equal to, or t minus 9 is 0, or t minus 4 is 0. We're going to add 9 to both sides. We're going to add 4 to both sides. And you end up here with t equal to 9 with t equal to 4. Now you solved a quadratic equation. Here we go. This highest power here now is 2. That's what makes it a quadratic. In terms of the variable t, however, if we go back to the original question, it's in terms of the variable x. So here's what we're going to do now. Since t here is equal to x squared, I'm going to replace t with x squared. In other words, this is really x squared now, and this is really x squared now. Let's write it a little bigger. This here is x squared, and this is x squared. So in other words, instead of t, we're going to call this now x squared. Okay? And I know it's really t, but we let t be x squared. So I now have 2 equations here to solve. X squared equals 9, x squared equals 4. Now, we can use the square root formula. X is plus or minus the square root of 9. X is plus or minus the square root of 4. So now x will be plus or minus 3, and x will be here plus or minus 2. We actually solved the equation in terms of x, which is what we originally had to solve here. That's what was given. X to the 4th minus 13x squared plus 36 is going to have these solutions in terms of x. Solution set notation looks like this. Since we have these plus and minus values, plus or minus 3, plus or minus 2, we're done. Here's our solution set answer. These are equations that are quadratic in form. So notice we're going to use all the skills and the tools that we had for solving to solve these equations. Number 3. X to the fourth minus 17 x squared plus 16 is 0. Again, we're going to let our t be here equal to x squared. That means t squared will be x squared squared, which is x to the 2 times 2, which is x to the fourth power. So now we get t squared minus 17t plus 16 is 0. This term here is t squared, and this term here is t. Solve by factoring. This is a quadratic equation. You can also use the quadratic formula. And I'd say this is minus 16 minus 1. So by the zero product rule, I get t minus 16 is 0. We get t minus 1 is 0. T will equal 16, and t will equal 1 if we add 16 to both sides, or we add 1 to both sides. We've solved this equation for t. But let's go back. T is really x squared. So I'm going to replace my t with x squared here. So I get x squared really equal to 16. I get x squared equal to 1. Now, we can solve this by saying, or using the square root formula, that if x squared is positive 16, x will be plus or minus the square root of 16. Here, x will be plus or minus the square root of 1. Plus or minus 4, plus or minus 1. These are my solutions. 4, negative 4, 1, negative 1. We're done. Number 5. Again, we're going to let t be x squared. So if t is x squared, we know t squared will be x to the fourth. So this here, t squared and t, we get t squared minus 11t plus 18 is 0. T. 9 and 2, both are minus. We're going to use the zero product rule. We're going to solve this quadratic equation by factoring. I get t minus 9 is 0, and I get t minus 2 is 0. I can add 9, and I'll add 2. We get t is 9, or we get t is positive 2. Now, what is t again? If we go back, t is really x squared. So I'm going to replace this t with x squared. So I get x squared actually is my positive 9, and I get x squared is my positive 2. By the square root formula, x is plus or minus the square root of 9, x is plus or minus the square root of 2, x is plus or minus 3, and plus or minus square root of 2. We can't simplify that radical, so we're done. These are my 4 solutions. Positive 3, negative 3, square root of 2, minus square root of 2. And you're done. This is number 5, I guess. Yeah. We're going to do number 7. Number 7, x to the 4th plus 5x squared minus 36 is 0. We're going to let t be our x squared again. So t is x squared, which means t squared is x to the 4th. So I get a t squared, I get a t, and we get t squared plus 5t minus 36 is 0. I'm going to solve this quadratic equation by factoring t, 9 and 4, plus 9 minus 4. So get t plus 9 is 0, and then I get t minus 4 is 0. So we're going to subtract 9 from both sides, and add 4 to both sides. So I get t here is negative 9, and I get t here is positive 4. So let's go back and let's be careful. T is negative 9, t is positive 4. Remember, we changed the variable from x to t, so t is actually x squared. So we're going to replace our t here with x squared. So we get x squared equals negative 9. We get x squared is positive 4. By the square root formula, x is plus or minus the square root of negative 9, and x is plus or minus the square root of positive 4. We know what the square root of negative 9 is. That's going to be 3i. And we know what the square root of 4 is. That's going to be 2. Here's my solutions. As a solution set, we say 3i minus 3i, positive 2, minus 2. You're done. This here is our solution set. And this is number 7. Number 9. X plus the square root of x minus 20 is 0. Now, like we discussed in the class during lecture, we're going to let t be this middle term. In other words, t now is the square root of x. So if this is t, and notice if I square both sides, I get t squared being actually x. So this term here will be my t squared term, because t squared is x. We get t squared plus t minus 20 is 0, a quadratic equation. I'm going to solve this quadratic by factoring. I get t plus 5. I get t minus 4. T plus 5 is 0, and t minus 4 is 0. Subtract 5, add 4. And now I get t being negative 5. I get t being positive 4. But let's remember, what is t again? T is the square root of x. So we can replace our t with the square root of x. We get the square root of x now is negative 5. We get the square root of x is positive 4. So let's take a look at how to solve these equations. Let's remember, these are radical equations. These are not quadratics. This is the square root of x. And if we remember the homework, what we need is the square root to equal a non-negative number. We need it to be positive or 0. In this case, it's negative 5. And that means this is impossible. There's no solution. I should really go back and say, well, there's no real solution. For this equation. So this doesn't contribute to our solution set. Now, the second equation, being the square root of x equals positive 4, well, that positive 4 is non-negative. There's going to be a solution here. We square both sides, and we find again, or we use our formula, that x will be 16. This is our solution. There's only one value here, and that's a positive 16. We're done. Number 11, we have x plus 4 times the square root of x minus 12 is 0. We're going to let t again be that middle term being the square root of x. And that gives us t squared being the x variable. So this is t squared, and this is t. We get t squared plus 4t minus 12 is 0. We're going to solve this quadratic by factoring. Let's see, 6 and 2 plus 6 and minus 2. So we get t plus 6 is 0. We get t minus 2 is 0. Subtract your 6 and add your 2. We get t equal to negative 6, t equal to positive 2. We solved for t. Let's not forget that t is the square root of x. So wherever there's a t now, replace it with the square root of x. So your equations now are going to become the square root of x is negative 6, the square root of x is positive 2. Here we have no real solution. This one's gone, doesn't contribute. Here we square both sides. We get x being 2 squared, which will be 4. Our single solution here is a positive 4. And that's again because negative 6 is negative. It has to be a non-negative, meaning positive or 0. And 2 was positive. So we could just simply square both sides. This is number 11. We're now hitting number 13. X minus our plus the square root of x minus 2 is 0. We're going to let this middle term be our t. So t is the square root of x, which means t squared becomes my x. So I get a quadratic equation in terms of t, where I get t squared plus t minus 2 is 0. This is where it comes from. And this is why they call this quadratic in form. Let's solve this for t. 2 and 1, that's plus 2, that's minus 1. T plus 2 is 0. T minus 1 is 0. We're going to subtract 2 from both sides. we're going to add 1 from both sides. T is -2, T is +1. We solve these for T. Let's recall that T is really the square root of x. So we're going to replace our T with the square root of x. And here's what we'll get. The square root of x is -2. The square root of x is +1. Here, no real solution. Does not contribute because that number has to be positive or 0. Here, the 1 is positive, so we can say, or we can square both sides. And then we can say that x is 1 squared, or simply x is the value 1. This is our solution set. 1. This is number 13. Let's look at 15. Here we have 2x to the -2 power plus x to the -1 power minus 15 is 0. Again, we let the middle term here be our t. So that t will be x to the -1 power. Now notice that means t squared is x to the -1 power to the second power. Let's write that a little better. And that means we have x to the -2 power because we're going to multiply the powers. What this means is that this middle term is t, and I get a t squared here for the first term. So that the equation really is 2t squared plus t minus 15, and that's the equation, or the quadratic, in terms of the variable t. So we're converting this equation to a quadratic equation. And now we can factor and solve and use the zero product rule, so we can solve this for t. This is a nice quadratic. So we have to find the values. Looks like it's going to be, so we got 2t squared plus t minus 15, 5 and 2, where this is positive and this is negative. Oh, that doesn't look like it works. It's not going to be the values. Okay. So 2t squared plus t minus 15, 5 and 3. So this is be 5 and 6. There we go. 5 and 3 instead. Now this will be positive and this will be negative. So that's going to give me what I need. And I have 2t minus 5 is 0. T plus 3 is 0. We factored. We're going to now have to add 5 to both sides. Subtract 3 from both sides here. We get 2t is 5. I get t is negative 3. I solve for t here. Divide by 2. And here I get t being 5/2. Now let's go back and recall. What is t again? T is x to the minus first power. Now, if you guys recall, this is 1 over x. X to the minus first power is 1 over x. So I'm going to replace my t with 1 over x. I get 1 over x. Now, these x's look weird. 1 over x is 5/2. I get 1 over x is negative 3. And I'll say negative 3 over 1. Now remember, we have to solve this for x, and what you're looking at is a proportion, which is equal ratios. Remember how we solve proportions? We cross multiply. Cross multiply. So you end up with 2 being 5x, and we end up with 1 being negative 3x. We have to solve for x. Divide both sides by 5. Divide both sides by -3. Cancellation here and here. We get 2/5 is the value x, or we get -1/3 is the value x. So x will be 2/5, or x will be -1/3 as a solution set. 2/5, comma, -1/3. And you're done. Number 15. This is 17. 3x to the minus 2 power plus 11x to the minus 1 power plus your 6 is 0. Again, my middle term is right here. This is my t. So t will be x to the minus first power, which is 1 over x. T squared will be x to the minus 2 power. So this is t squared, and this is t. 3t squared plus 11t plus 6 is 0. We have a quadratic equation that we can solve by factoring. So let's try this out. 3t, t. We can use 3 here and 2. That gives us 9t plus 2t is 11t. Okay. 3t plus 2 is 0. T plus 3 is 0 by the zero product rule. Let's solve these equations. Subtract 2, subtract 3. We get 3t is -2. We get t is -3. Divide both sides by 3. Let's see what we get. T is -2/3 in one case, and t is -3 in one case. Let's not forget here that t is actually 1 over x. Okay, so replace t with 1 over x here and here. So we end up with 1 over x being -2/3, 1 over x being -3. Pretty similar. Got a little deja vu. Okay, cross multiply because we're looking at a proportion. And you might say, but what about on this equation? Well, divide by 1. So we get 3 being -2x, and we get 1 being -3x. Divide both sides by my -2 and by a -3. I get -3/2 is x. I get -1/3 is x because I have cancellation. These are my solutions. So if I look in back of the book, I'll see -3/2, comma, -1/3 in terms of a solution set. Number 19. Three plus the square root of x squared plus 3 times 3 plus the square root of x minus 10 is 0. Okay. Again, we're going to let this middle term be t, so that t is 3 plus the square root of x. And then notice that t squared becomes just simply square both sides. This is your t squared term. we have a t squared plus a 3t minus 10 is a 0. A nice quadratic equation to solve. We can solve this by factoring t. Looks like it'll be plus 5 and minus 2. So we get t plus 5 is 0. We get t minus 2 is 0. Okay. I'm going to subtract 5 here from both sides. And add 2 to both sides. Let's see what we get for t. T is negative 5 and t is positive 2. Two values for t. Go back up here. We know t is really 3 plus the square root of x. So we're going to replace this t with 3 plus the square root of x. Both of them. Three plus the square root of x is negative 5. 3 plus the square root of x is positive 2. So we're going to solve for the square root of x here. We subtract 3 from both equations, and we end up with the square root of x is negative 8. The square root of x is negative 1. Now, here's an issue. In both cases, the square root of x is equal to negative numbers. They have to be non-negative numbers. So here there's no real solution. And here there's no real solution. In other words, the answer is simply there's no real solution. Or the solution set is empty. And that's what we get for number 19. Number 21. 1 plus the square root of x squared plus 5 times 1 plus the square root of x plus 6 is my 0. We're going to let this middle term here be t. Here's t. So that t is 1 plus the square root of x. This will become t squared. So I get t squared plus 5t plus 6 is 0. T, we're going to factor. Plus 3 plus 2. T plus 3 is 0. T plus 2 is 0. Let's write this a lot better here. T plus 3 is 0. T plus 2 is 0. Subtract 3 from both sides. Subtract 2. Here we get t is negative 3. And then t is negative 2. Now, let's go back and recall here. We solved this for t. T was actually 1 plus the square root of x. So I'll replace my t with a 1 plus the square root of x in both cases. Let's try to solve this. 1 plus the square root of x is negative 3. 1 plus the square root of x is negative 2. We're going to solve here for the square root of x. We get the square root of x here is negative 4. The square root of x here is negative 3. Again, no real solution for both of these. Therefore, there's no solution here. (23) x squared minus 2 squared minus 12 times x squared minus 2 plus 20 is 0. Replace the middle term here with t. This is my t. So t becomes x squared minus 2, and that makes this actually t squared. So the quadratic you get is t squared minus 12t plus 20 is 0. We're going to factor t and t. It looks like we're going to have minus 10 and minus 2. So t minus 10 is 0. T minus 2 is 0. Solving for t. Add 10. Add 2. T is 10, and I get t is 2. Let's see what this gives us. Let's not forget that t is really x squared minus 2. So I'm going to replace this t with x squared minus 2, x squared minus 2. And we end up with here x squared minus 2 is 10, x squared minus 2 is 2. Well, we're going to add 2 to both sides for both of these equations. And we get x squared is 12. X squared here is 4. We can solve both of these by using the square root formula. That means x is plus or minus the square root of 12. X is plus or minus the square root of 4. Let's be careful here. And I can simplify the square root of 12 here to be 2 square root of 3. And the square root of 4 is actually 2. So I have my solutions here. 2 square root of 3 minus 2 square root of 3. Positive 2 and a negative 2. You are done. Number 25. We have 4x minus 1 squared minus 8 times 4x minus 1 plus 12 is 0. Again, we're going to let the middle term be our t. So t will be 4x minus 1. Here's my t. Here's my t squared. I get t squared minus 8t plus 12 is 0. Let's factor t, t. Factors of 12 that add up to negative 8. I'm going to solve this by factoring. 6 and 2, minus 6 and minus 2. So we can solve these. This is t minus 6 is 0, and this is t minus 2 is 0. So let's now add our 6 here to both sides and add our 2 to both sides. We'll get t is 6 and t is positive 2. Okay. Let's go back and think about what t really was. This is 4x minus 1. 4x minus 1. So we're going to say 4x minus 1 is positive 6. 4x minus 1 is positive 2. We're going to solve for x. Add 1. For x is 7. 4x is 3. Divide by 4. X is 7/4. X is 3/4. Seven fourths, comma, 3/4. And you're done. Number 27, 9 x plus 2 over x plus 3 squared minus 6 times x plus 2 over x plus 3 plus 1 is 0. We're going to again let the middle term here be our t. So t is going to be x plus 2 over x plus 3. This is my t, which makes this my t squared. So I have 9t squared now minus 6t plus 1 is 0. A quadratic equation. Let's see what this is. Looks like we have 3t minus 1 times 3t minus 1. Okay. 3t minus 1 is 0. 3t minus 1 is 0. It's the same equation. We just have to solve one of them since it's the same. So we get 3t is 1. Let's divide by 3. And we have t being 1/3. Now let's not forget what t really is. T is this rational expression here. Let me be a little careful here. T is what you see here. So we're going to use this. We're going to replace t now with this fraction, which is x plus 2 over x plus 3. So here this is x plus 2 over x plus 3. So we get x plus 2 over x plus 3 is really 1/3. You're going to use cross multiplication. This here is a proportion. So this becomes 3 times x plus 2, which is 1 times x plus 3. We're going to have to solve this for x. Now don't forget to distribute here. So you have 3x plus 6. I can distribute here as well, but 1 times anything is itself. This is a nice linear equation. We have 2x plus 6 is 3. We're going to now subtract 6 from both sides. And we get 2x is negative 3. Divide both sides by my 2. We'll get x is a negative 3/2. This is my solution. Let's put this in black. And we're done. We're going to get down to number 29. So we have x to the 2/3 minus 2x to the 1/3 minus 8 is 0. I'm going to let my t be the middle term here, meaning we're going to let t be x to the 1/3. Notice that means t squared will be just simply square both sides. That's x to the 2/3. Multiply your powers. So here's my t, and here's t squared. I have t squared minus 2t minus 8 is 0. We can solve this by factoring t and t. It looks like we'll have 4 and positive 2. So using the zero product rule now, I get t minus 4 is 0. I get t plus 2 is 0. I'm going to add 4. I'm going to subtract 2. T is 4. T is negative 2. Now let's not forget, what is t? T is x to the 1/3 power. I'm going to replace my t with x to the 1/3. So you now end up with x to the 1/3 equals 4. And x to the 1/3 is a -2. Okay. This is a cube root. Now, how we can handle this is we're going to actually cube both sides. Now, it doesn't matter if I have a negative, like for the square root. This is x is 4 to the 3rd power. This is x equals -2 to the 3rd power. Because cube roots can be negative. We're looking at this right here. So this gives us x to be 64. This gives us x to be a -8. Both of those are essentially possible. Let's go back for a second and think about this. This is the point I'm making. X here to the 1/3 power being a negative number like a 2 here. This is the cube root of x. Let's not write it down there. Let's move this. Okay, here's the point. We have the cube root of x being -2. Now, this is not the square root. This is the cube root. And let's remember that it's possible for a cube root to be negative. Okay, it's not possible for a square root to be negative and have a real solution. But for a cube root, definitely is possible. So what I'm saying here is, it makes sense to cube both sides. Get x being -2 to the 3rd power, or x is actually -8. That's a solution. If you recall, we have to get a true statement here. So if x is -8, we're saying the cube root of -8 is actually -2, and it actually is. This is a true statement, so it's a solution. So what I'm saying to you here is, when we were back at this point to cube both sides, and I noticed here that this number here is negative, that's not something we can do when we're taking square roots or squaring both sides. This is a cube root, not a square root. We allow cube roots of negatives. They're perfectly fine. They exist. They're real numbers. So this is the detail you have to remember. And it looks like our solutions here are, looks like we erased something here. It's supposed to be -8 and +64. This is my solution set. And we are done.